So in today's session, I would be talking more of the cultural perspective of DevOps, the conceptual perspective of DevOps, and on the tooling side, we would be looking at what we are going to build as an end product. So whatever would be covered during this course at SRYIT, what is the end goal of it? So unless and until we have a target in mind, we will not be able to proceed in that direction, right? So very first, let's talk of what DevOps is. There have been multiple problems in industry. Uh, 20 years back, when people started to think about the routine software development process, they came across some new ideologies, some new concepts. So they started to think across agile. And later on, after 10 years, so almost 10 years back the line, agile was formed. And these agile concepts were slowly being taken away by the big industries first, then the small industries. And today, each and every company out there looks to be agile. So they are thinking of something like scrums, sprints, daily achievable goals, finishing off with the software at the faster pace because their customers require so. All the businesses, majority of the businesses which you find on internet are based on some of the services. They have their own softwares, their own services, their own apps that have to be designed, published, modified according to the seasons. New features keep on adding every now and then. But at such a large pace, how do you keep up with software development, right? So the answer for that was agile. We don't use any waterfall model, so the rigidness of software development is all removed. People code every day. So what the points where agile really shines is that we have everyday achievable goals. So there are modifications every day. There are commits happening every day. Okay, so the dependencies might change. And of course, it happens regularly. So if the dependencies are changing, your software is changing, the features are changing, that means your code changes. Code changes, the environment in which it runs would also change, right? It also happens to change. So if this is the output of agile, now all these would be the byproducts, okay? Rather we say that it would be an overhead on the ops side. So there are two teams in a company. First team is the developer team that would be practicing agile from core of their heart. So I would say this is a dev team. And there is another team which is there. It's called a ops team. So what's the problem with ops? Ops is that okay, if you're trying to do this every day, we will allow you to do that, but with a limitation. The limitation is we will not be releasing your code every day. Okay, so releases are not regular. You happen to release the code maybe every 1 month or 3 months or 6 months duration. And what happens during these cycles is that very first the code is developed, then the testing team takes over, then they test that. By the time that happens, the developer team is still sitting idle. Well, that is a big problem, right? Whenever you practice a good agile methodology, your team shouldn't be sitting idle. Everything should happen in parallel, right? So if you want to do that, then a lot of code would be accumulated over a span, right? The code is accumulated, it becomes buggy, it becomes tedious to manage. Your clients are still waiting for your new features, but you're not ready to release it because your ops team cannot take in the changes at that pace. So we came up with a new idea that if configuring the systems is too hard and making or doing the stuff manually can be buggy at times because we cannot trust humans not to make errors in a long scripted steps, right? So if you have 1,000 nodes to be monitored and controlled and installed, configured, and then set up in the network, probably there would be an instance or two of the errors. But when you need 100% uptime, so there are some constraints that we are trying to achieve. Okay, the constraints are very first we need near to 100% uptime. So if you happen to do an event, that means release, maybe every month, and that release requires you to take your systems down, okay, and then deploy the code and then test it and then take them up. It would be almost a drill of 30 minutes or so if you do it really fast. If not, might extend to an hour or so, or maybe even 4 hours if things don't go right. But if that is happening, you would be having a downtime of 4 hours in a month, or maybe in a 2 months, whatever release frequency you have. When that is happening, what do you think would be the uptime of that particular application? It would definitely be less than 80%. Okay, so what is 100% uptime? If you're talking of in year, 365 days, near 100% uptime, that means 5 nines guarantee means you would be having less than 5 minutes of downtime every year. That's awesome to hear, but it is very tough to maintain. So DevOps comes in between. DevOps says that, okay, if you are having these constraints, moreover, the stakeholders would be expecting the code. Okay, there are expectations from the clients. They need early interaction or early involvement. So this is the important factor in managing agile, that you should be getting the customer involved as soon as possible, so that you don't throw bigger features at customer and then they reject it. Rather, you make a small change and then ask them for approval whether it is working fine or not. If it is not working fine, they would be getting back to you with the feedback. So you make changes in time, and you don't have to bear a cost of untimely major changes inside your software. Okay, so we have seen all the three sides: what Dave says, what ops says, and what the business people say. How do we solve it? We see that there is a problem with the way ops is maintained, because the development side, we have already making changes 10 years back. We have joined the agile methodology. Culture is all set. Everyone is developing the software at very good pace. We don't have anyone sitting idle. Awesome jobs. On the ops side, this is not a regular release. It happens after a few months. So that's a big event for them. So whenever that happens, all these people are all on full alert and attention. So they want that there should be lesser downtime and best release should happen. Well, just tell me that if uh, we do the things regularly, would it be an event for us? No, it wouldn't, right? So if you do something on regular basis, let's say in the initial days when Facebook was out and I didn't have any internet, I would go to my friend's place or a cafe and then check my Facebook account. That was a big event for me back then when I was a kid. But now I check it regularly, so that's not a biggie for me. I would say if someone posts a comment, okay, that's no biggie. I would check in the evening or I'd check the other day. Just like that, if you happen to release every single day, or if you want, if you get to that automation level where you are able to release anytime you want, rather than making some preparations for whole month and then doing the release cycle. If that happens, it would be a no event for that ops team, right? So this bridge is now created because of the DevOps team. So what DevOps does is DevOps would be bridging up the dev and the ops teams together. So development teams who are sending the changes and the ops team which are registering the changes would come together to form actually a heterogeneous team. That means a team which consists of people from different areas. So in DevOps, we have infrastructure experts, okay? Then we have automation experts, we have testing team, we have DBAs, okay? We have developers, and we have architects. So DevOps is not about just one single person or even a person or a team who knows just about the stuff and all of them are on the same page. No, this team is heterogeneous. All the people who are joining DevOps would be from the ideal DevOps team I'm talking of, would be from different areas. And when all these people sit in one single team, if a problem comes in, that something is not working. If a development guy finds that something is not working on the web server end, even if he is not aware of what goes inside of a web server, he can escalate that within a team, and communication within team is really fast. It happens horizontally. You don't have to wait for approvals, don't have to send the data out, okay, don't have to wait over the mail threads to get the things back. So that's the fastest way, right? Another way is that what we do in the DevOps team, we regularly change hats, we change roles. So if today I'm in charge of the web servers, tomorrow I would be then in charge of the DB side, or maybe day after tomorrow I would be in charge of continuous integration stuff. Okay, so that's how you change roles. So in DevOps, there would be many jobs which are available. Generally, the jobs are like this. Let me write it down for you. The first job is a DevOps engineer. So this DevOps engineer is a person who knows everything, not everything, something about everything. Okay, so he's a jack of all trades and master of one. So a DevOps engineer needs to know all the stuff about the infrastructure that is being built. He should be able to tell where the code is created, how it moves to the CI engine, how it moves outside to the production, and how are the people using it. What are the statistics of it? Okay, if you don't have any statistics, DevOps is a failure, because without statistics you cannot optimize. Not compare what was happening earlier and what's happening right now. Another role is for build and release engineer. Okay, uh, these people would be responsible for building your code and preparing them into final deployable artifacts. Then there is automation engineer. Now, automation engineer would be a person who takes care of automating all your stuff. Okay, installation of tools, integrating them together, uh, preparing the scripts for deployments if they are required, integrating the tools together, setting it up on the developer end, getting the stuff like Vagrant, Docker up and running. So that's what is the role of an automation engineer. He would also be responsible for running the test cases on the CI engine. Okay, then we have specialized jobs like a chef engineer or puppet engineer. Okay, or very specifically it could also be something who's some people who are requiring Jenkins guy, so a person who needs sorry, a person who has exposure to a specific tool. So there are tool specific jobs as well. Okay, so that's about the job side. How do we solve the problem that we are looking for? To solve the problems, like I said, the team is heterogeneous team. Everyone knows like the team would know everything about what's happening in a company, on the coding perspective, on the production perspective, because they hold the knowledge of each and every area. And every day, maybe every few days, they change the hats, they change the roles, so they get to know more. Okay, from the cultural perspective, how do you set up a good DevOps culture? To set up a good DevOps culture, all that we need is to remove the ego. So this is a no blame game. So we say there should not be any blaming. Okay, there should be initiatives, there should be innovation, there should be horizontal communication, there should be a sense of responsibility. Now if this is missing, what happens? If you are a part of bigger organizations, you might already know what I'm talking of, because all these things are generally being visible in bigger companies, larger teams. So whenever something goes wrong on production, Okay, so I'm not the one who is supposed to be blamed. I would just clean my slate and I say, okay, it's not me, you look for someone else. So the code that I committed, it was working on my machine, that means it is perfect. You do whatever you want to do. It's not working on production, it's not my uh, problem. Okay, you did something wrong. So this is how people blame one another. What DevOps team would do, a person from DevOps team would do, if something is wrong, something is not working, if he identifies that, even if he is not responsible for it because he has not created it, DevOps team would sit somewhere else. The developer teams are different. So if developer commits a faulty code, it's the responsibility of the DevOps team to check it, to identify the cause, and prevent the failures before it could hit the production. Okay, so at some point, the hierarchy joins the DevOps team. So you are responsible for what's happening and what's going on the production. So if something goes wrong, instead of sitting idly, you could escalate that problem as soon as possible if you're not able to solve it to your teammates. Okay, even to the corresponding developer who is responsible for finishing off with the code. Then taking initiatives. Now, where the automation strucks, because DevOps is about automation, right? It bridges the gap between your agile, like flexible agile and static ops teams. So we are doing automation here. We are helping the ops team to automate all their configuration stuff. All their infrastructure handling has to be automated. So DevOps would be bringing life to the infrastructure by changing the way it is managed. We call it as infrastructure as a code. You change one single line of code and your infrastructure will start behaving according to it. Okay, we'll see in the coming classes how infrastructure can be handled. There are multiple tools that are available there. Why do we use tools? Because we don't want to reinvent the wheel. People have already been there, they have created solutions. Okay, if you are facing the same problem, use the same solution that they have used and move ahead. You don't have to reinvent all the stuff that they have gone through. So I was talking of DevOps as an automation. So DevOps provides you with automation. It tries to automate everything that is there which is related to code, from the code commits to code integration. Then there would be the testing part, the code builds, evaluation, configuration, infrastructure setup, deployments, monitoring, logging, analysis. And to every single step that I'm talking of here, there would be a solution for that. Okay, either you would be finding one single integrated solution that handles all of these things. Okay, so there are a few softwares that will help you with deployments, then configuration, evaluation, build, testing, integration part. So one such tool is called Bamboo from Atlassian, if you know what I'm talking of. um, Jenkins would help you with until evaluation part. Integration to evaluation, it does not handle the commit section would be handled by your subversion or git. Okay, or revision control systems which are there. Then the infrastructure setup would be managed by some infrastructure management tools like Cobbler is there, Foreman is there. Then the deployment section would be handled either by your continuous integration softwares or by uh, some specialized softwares like Capistrano. Then there is monitoring, Nagios, Sensio, Xenos, New Relic. Logging part would be handled by either Papertrail or Loggy or Logstash. Analysis part, again, there would be static analysis tools. The logging tools would help you with analysis of the logs as well. So if you're dumping the log somewhere, like Elasticsearch, then you could create your own ETL mechanisms for searching and analyzing the data. Google Analytics is another way of going through this stuff. Okay, so there are tools which are in falling in each and every section, but how do we set it up? So in the class, we will be talking a little about culture. We will be talking a little about what structure is, okay, and a lot about automation. The reason why we are keeping it short on the culture and structural part, because it needs sponsorship. Setting up the culture and the structure of your teams in a company is the responsibility of the company stakeholders, the company's management, okay, and they would be needing another few classes for setting it up. From our perspective, what we could do is we could enhance person to person communication best. We could have inter team, not inter team, intra team culture to be set up. And on the automation side, we need a lot of technical help. So you'll be concentrating more on the automation. So in this course, what are we going to do? We are going to look into a few tools, okay, and at the end product we will be building an infrastructure that is available, that is able to scale itself and sustain under heavy traffic. So what do we need? I'm having here a few support systems. So I would be building this infrastructure that I'm drawing on screen right now. I need a developer machine, okay. So this is a use case that is generally followed all across the globe for any of the big small software projects. It can be tuned and modified according to your requirements. So the developer person commits the code. He is ready to share the code with others. The code is production ready for his particular feature. The code goes to some revision control system or a central server which stores the code and history for you. So I would say it's a revision control system for me, or source code management. Now from the source code management system, there would be a continuous integration software. Let's call it uh, short. There would be some continuous integration software. I would be using Jenkins for the demonstration purposes. The from SCM, continuous integration software would be pulling your code. It would be validating it, testing it, building it. Okay, all your different stuff that you would be doing. That means UAT testing would be there, your regression testing, um, any different kind of testing that you want to automate. Then UI testing. Okay, building the code is another a big step in all itself. You could be building the code on different machines, different architectures, and all of those stuff can be taken care by continuous integration. It is not a small step, it's huge, it's really big. Then from continuous integration, the code might be deployed to some of the pre-production systems. Okay, so this is called pre-production environment or staging environment. The continuous integration software will be deploying it there. Configuration software is also responsible for pushing the code from pre-production to the production side, but it completely depends on how you set it up. In our case, we would be keeping it separate. So what we need is we need a system for configuration management. So what configuration management is responsible for? Configuration management systems like Puppet and Chef are responsible for setting up the infrastructure for you. That means automating the infrastructure side, where the people were spending hours and hours of time to set up the machine and then put it into production. Today we need those machines within minutes. Because let's take an example. Amazon recently had a big sale for last 7 days, and even Flipkart had big billion day sales coming back, right? So the traffic that these people were expecting was almost 3 times the regular traffic that they generally achieve on any single day. So how do they scale up their infrastructure? Okay, do they order more machines, or do they sit all night configuring those boxes? Thousands of boxes, they would be needing thousands of men. Well, it's not like that. When YouTube was actually taken over by Google, YouTube just had 5 to 6 different engineers. So there were some engineers, a developer, a DBA, a tester, and an infrastructure manager. Okay, so a small team serving hundreds of millions of people, and their capacity was increased from March to June. In 3 to 4 months, they rose more than 3x. So the traffic was 30 million people, and then the user base increased to 100 million people within 3 months, and they were able to scale it up. So that's what we are trying to do here, but with a small setup. So the pre-production configuration management would be picking up the stuff, and it would spin up the nodes for us. It would create the infrastructure for us. So we would be having different nodes. In the node side, what I need is we would be having a database, okay, a machine that would be responsible for serving the data. Then for a general architecture, we would be using some web servers, or call it web 1. We would be creating a cluster of it, web 2, and so on. It would be falling in tiers. So we'll talk of what the different network configurations are, how to set up the networks, what are the layered tiers, okay, and how it works at the data center level. What are availability zones? Why not to place the same? Why not to place the machines on the same rack? Where to keep the data? How to choose the availability zones, and how to scale your systems from there. So the configuration management system is responsible for your code deployments and replication in the current scenario. Okay, or you could go from configuration management to some intermediate node which would be handling the deployments for you, or have a deployment management system altogether different. Okay, continuous integration systems can also handle deployments. It's a varied kind of environment. I'll talk of each and every perspective of it so that you get to know which ones to pick up whenever it is required. It's not a good idea to pick up big tools for a small problem. If it can be solved by simple commands or tools, feel free to use them. Because I have seen people who did DevOps just with rsync, a simple copy command, okay, and a few scripts. So it was as easy as that. DevOps is not about fancy tools. It's about automation. If it automation as simple as it could be, if it works for you, it's perfect DevOps. Then we are talking of web layer. Then there would be LB, or load balancer, okay, that would be serving your public ports. Data moves in like this. So this section here, the load balancer section, is a public section. Router would be connecting to the load balancer. The load balancer would be connecting to the cluster. It would be serving the data, the request to the cluster, and the cluster would be serving the data from your internal systems. So it becomes difficult to understand where to cut short lines. Okay, so we divide the section into three different areas like this. Okay, so the different areas where the DevOps is broken down into, it is continuous integration, continuous deployment, continuous delivery. If you are not a DevOps team, all the continuous words would fade away. There is nothing continuous in your infrastructure. Okay, the people from Bitbucket, they or Facebook, they tend to deploy every day or every few hours. If they need a turnaround time of 5 minutes, if something is wrong, they are able to fix it and release the stuff as soon as possible. They don't want their clients to wait even for a single minute more. Okay, so that's the achievement or a stage that we want to achieve as a DevOps team. So these three areas, continuous integration starts with the code inception, right from the developer machine. There would be some hook scripts, some building mechanisms, some automation scripts that are running, which would be checking the code in the background or testing the commits before they happen. They would also notify the developer of the any problem if there is any. Okay, at every level in this complete architecture, there would be support systems supporting you, and there would be feedback loops. If anything goes wrong, the person who is responsible for it should be getting the proper notification or an email, so that he does not have to wait for longer durations. If a person waits for 7 days for getting a bug figured out, after 7 days, do you expect him to go back and fix it at the same pace at which he was working? No, because the context switches. Okay, and there is some psychological aspect that is behind it. So we don't want people to switch the context. As soon as they commit, if you are able to get back to them within a few minutes, they would be happy to fix it for you as soon as possible. Okay, so every level would be having a feedback loop. If something goes wrong, it's continuous integration. Continuous integration software knows that okay, this person has committed the code, and he should be mailed that okay, this is something wrong, you need to fix it. Same thing with pre-production, same thing with the configuration management softwares and at the web levels. Anything goes wrong, a person who has done it should be able to fix it. As simple as that. So when you set it up, the sense of responsibility is automatically built in the teams. Because if I'm responsible for my code, I would be present at every single stage of it. I know where my code is in the complete cycle. No one would be taking credit for that. No one would be stealing the credit for me for that particular line of code that I've written. What generally happens in bigger teams, because the hierarchy is too huge, you do some work, your superiors would be taking the credit for it. So when this happens, people lose the sense of ownership. They say that okay, I'm not responsible for it, someone else is taking the credit, so let him handle all the stuff. Okay, that is not what we want to do here. So I was talking of continuous integration, which starts with the developer machine, ends to the point where you have deployable artifacts ready. Okay, so this line, the first one, is all continuous integration on the left hand side. The pre-production area, where continuous integration would be dumping the deployables that you have created, tested in a production like zone with all your regression and smoke testing been done at these areas. It is called continuous deployment, and that should happen continuously. As soon as you have a deployable artifact ready, you would be deploying it, testing it, making it production ready. Okay, so pre-production machines most probably would be having the same configuration, okay, and setup as the production environment. Good companies who are having really nice DevOps teams, they would be setting up the pre-production environments right on their production machines, but they would be isolating that part out from the public. So the setting up the stuff here on the pre-production and managing it is continuous deployment. And whenever the code would move from pre-production environment to production, so configuration management, setting up the production environment, automating it, monitoring and logging on the production side, it's all the part of continuous delivery when you are actually making some money out of it. So if anything goes wrong on the continuous delivery front, you would be losing your uptime, you would be losing money on that side. Okay, and this is the reason why ops teams were too much skeptical about changing the stuff. It is, if it is already running, let it be running. Why to mess up with that part, right? But we say that if we can automate that, and if it runs on one single machine, I can easily replicate it over the 1,000 different boxes. I don't need to worry about it because computers cannot do anything wrong, right? If you set it up to spell ABC, it would spell ABC every single day, right? So that's how it would work. Now talking of the support systems, what are the support systems that we would be needing? We would need DNS, we would need DHCP, okay, we would be needing NFS share, we need automated installations using PXEs, which is a pre-execution environment that we would be setting up. We need continuous integration systems like Jenkins. We need SCM or source code management systems like Subversion and Git. Okay. Then we would be talking about the different database architectures that are available. Okay. So we would be talking about DBs. We would be talking about virtual machines. In coming time, there would be a lot of shift in virtualization area. So we will also be talking about containerization, which is Docker. Okay. In the continuous integration side, we'll also be talking about some build tools. So I'll be covering a little about Ant and Maven. Logging and monitoring, we would be covering Nagios and writing Nagios plugins. So that's the big picture that we would be drawing till end of the class. Okay, so this is the final output that you should be looking to. So if you want to add more clusters or even add more servers to your clusters, what you would be doing is you can easily scale up Web 1, Web 2, moving to Web 3, Web 4, and Web 5 If DB has to be replicated, the DB replication factor is not generally it doesn't have to be hard coded or written any scripts with. So what DB replication would be done with is they have their own capabilities. So databases would be coming up with their own capabilities of replication and backup. So according to that, you will have to set up the databases. If you're using Cassandra or NoSQL databases, they would be eventually consistent, and they can take care of their own replication in ring-like structure. But if you're talking of something like MySQL or Postgres, they work in the older fashion where all these boxes are running in primary, secondary mode or master-slave mode. Okay, so you'll have to take care of that. So that's a specific section about the databases. Load balancers can be run in fail-safe mode. We take care while we provision the machines. Provisioning means to set up a role for a machine. So whenever we provision a machine and install and configure it, at that time we make sure that there are enough replication copies available. Okay, and there is no single point of failure in the complete infrastructure. We would be starting one step at a time, starting with DNS and DHCP. Before that, we'll be talking of concepts, then DNS, DHCP, setting up NFS, PXEs, then moving to the continuous integration side. And to integrate all of this stuff, we would be learning Bash and Python. So that should help us in integrating all these stuff together if you need to. Even if you want to code a few things, write a library, or use an API for your own custom purpose for which the tools may not be a good fit, always feel free to use any scripting language. Don't hesitate to do that. Okay, don't keep on looking for the tools if your problem is too trivial and it's too small. All right, so that's 40 minutes of mine. I still have 20 minutes that I have reserved for question and answers. So since this is a demo session, feel free to ask or shoot any questions you wish to ask, and you can also share your experiences or your backgrounds so that we can make some modifications with whatever the course contents are, and also the delivery perspective. All right, any queries?
Hey Ashish, this is Sandeep.
Hi.
Yeah, my question is, where in this total, what is the use of Docker?
Okay.
Because basically it's cloud technology, um, cloud application.
Well, I wouldn't say Docker is a cloud application. I wouldn't say VMs are a cloud application even. Now, these are the
Okay,
separate technologies which are being used uh, in cloud to set up the infrastructure for you. Okay, so
okay.
that's the basic
Apart
idea.
Docker, anything we can replace with in place of Docker, we can replace anything.
We cannot actually, because that completely different section, and that's the only tool which is shining in that section right now. Otherwise, we have different containers like LXCs, the crude containers which are not having any interfaces. Docker is a technology that uses LXCs in the background. Okay, another tool is Packer that Windows uses, but it is not too stable and it is not being used in production at all. And moreover, 80% of the systems out there are Linux machines. So what Docker would help you in is it is a lighter version of VM. It doesn't hold any of the binding with the kernel, so it does not have any kernel of its own. What it uses is union file system, which would create some layers on your boxes. So you could spin up multiple services on a single machine in isolation. Okay, that's the benefit of Docker.
Okay,
Okay, if you're talking of VMs, if you spin up a VM, it would take a specific resource. You'll have to grant some resources to the VM, even if you spin it up on a hosted hypervisor like we would be doing in the classes. We would be talking of virtual machines in VirtualBox. So I have a software called Oracle VirtualBox that we will be using. If you spin up a machine, it would be having its own kernel, its own operating system layers, its own process management, its own memory management that eats up almost 50% of the RAM that you allocate to it. So it is very tough to manage the resources with VMs. We waste a lot of resources with virtual machines. With Docker, it uses the resources from the host box itself. It doesn't have its own kernel. It doesn't have its own process management or memory management text, it uses all the features from the underlying operating system, from the kernel that the Linux machines would be providing it. All it needs to do is to manage the namespaces in which the processes are running. So that's why Docker is really shining these days, because we would be really light on the resources. Even on the cloud, infrastructure is a really costly affair. Okay, that's why people are jumping to clouds from VM these days.
Okay. Okay, Ashish. Thank you.
You're welcome. Okay, let me tell you how I would be going about covering this course. Well, as you might know, my name is Ashish Nanodkar, and I'm having 7.5 years of experience as an IT engineer. So I'm a full stack IT engineer. I'm not coming in from very specific testing background or very specifically ops background. I'm a full stack engineer that knows every area of it. Then I chose to move to DevOps, and these days I'm acting as DevOps coach and helping bigger teams and companies to set up DevOps all across their projects. Okay, so that's what I'm doing for living these days. About the course, I'm not a big fan of theoretical stuff. So presentations would be minimum or not, no presentations at all. It would be all live in front of your eyes. We would be picking up one tool at a time, setting up the infrastructure, building it one step. Okay, so that's how I would be going with this course. It would be all practical session. Theoretical part would be covered whenever it is required, whenever you need more information of it. Okay, I would be sharing the course material and links and the websites where you should be looking for the information, because it's not a good idea to go for complete reference systems or websites right away. If you are given a Docker documentation or maybe Chef documentation, a complete of it, you would find yourself lost. Okay, so that's why I have figured out the small and best links and URLs that I can help you with. So that's the best way to start learning. And I have presented to you the last target because if you have a problem ahead of you, you can definitely think of a solution for it. Okay, and that's the good way of learning things. That's how I learned. I first created a problem. So we need to solve this. That's why we need to learn. So there's some aim in mind. That's why people learn. If you're just told to learn a tool and you don't know where it would be implemented or used, it's of no use, right? So that's my teaching strategies for any of the classes that I take. Any queries from your side? We still have a good 15 minutes. We can talk, discuss any question that is related to this, not related to this. Feel free to ask me. Or any use case that you find a little weird, which is happening in your organization. If you want to share, we can look for the solutions here as well. Feel free to bring in the use cases or case studies from your side. Okay, no queries. Surprised.
I think we are good to go, Ashish.
Okay. Thanks, Sandeep, and thanks everyone for your time. Well, if you don't want to speak on mic, you can definitely chat with me. I'm open to that as well. Yeah, Sharon. So, what the stuff is, see, we take up the course only because
Yeah,
we are
actually,
new
we are new
to.
to this tip. Yeah.
Yes. So we take up the course only because we are new. So,
Yes.
what are the prerequisites? Would be a good question to ask. Um, the prerequisites for this course is that you should have a little knowledge about programming, because that's
Hmm.
a new area if it's new to you. If you haven't coded any time in your life, then covering Bash and Python would be a tough deal for you. You'll have to work harder. Uh,
Okay.
you must be having a small interaction with Linux. You must at least know how to use Linux desktops. I'm not expecting any CLI level integration or interaction of you with any of the Linux systems, but you should at least know what the stuff is. Um, that becomes little easier for me to take up the things. Otherwise, you will feel yourself to be lost. That what's happening, okay, in the class. What I expect again is that I would be telling you the topics that we would be covering in the next session. Okay, so please come prepared with the terminologies. That's what is expected so that we can speed up with the things and finish the stuff in time as well as in depth. Okay, that's what my expectations are. What do you people expect from me? You can feel free and let me know. If anyone thinks he's falling short on any of the prerequisites, we can have a solution over it. Just let me know that what you think about it. Okay, good question. That how much time would it take and how many sessions? I target to finish this up in next 30 hours. So if we have 30 hours, 8 hours a day, it would also work. If you're willing to spend an hour a day, it would take 30 days. If you're willing to spend hour and a half a day, it would take 20 days. Okay, 5 days a week if these are the weekly classes. If we happen to set it up on the weekends, it would be 3 hours a day. So 6 hours a week would finish up in almost 4 weeks or so. Okay, 4 5 weeks max. That's how I break down the things. It all depends on how much time we spend a day. I'm targeting to take it up as 1.5 hour a day, 5 days a week. That would almost cover 7.5 hours every week, targeting it to 4 weeks. And definitely it is flexible enough. So if you happen to pick up things faster, so we can finish it up in 24 hours as well. Some teams with whom I've worked with, they have taken as long as 40 hours. Now, it depends on how much questions or at what depth they want to reach. Okay. Uh, you taking initiatives, it's good for me because you'd be coming up with good questions, targeted questions, so that I could drive the discussion into a deeper level. Otherwise, it would be at a level where I can ensure that you guys can diversify yourself above it. So I would bring you all to a platform where you can understand and figure out the stuff for yourself. Okay, that's what my initial target would be. If you want to drive yourself deeper into it, do your own research, get back to me with questions. I would be happy to help you with that.
Okay.
Thank you, Ashish. Thank you very much for your time.
Yeah, thank you everyone. So let me tell you the class timings which I've received from SRYTI guys. It is going to be 8 a.m. IST, which is supposed to be 9:30 p.m. for you. If it's okay, just
Yeah,
let us know.
yeah, okay for us.
All right. So it's great to have you here on the call. I would see you again whenever the class is scheduled. All right. Have a great day ahead, guys. Thank you so much.
Thank, yeah.
Thank you. Thank you.
You're welcome.